Why do we keep using technologies that we know are worse, even when better ones already exist? This isn't just annoying, it's one of the reasons climate change is so hard to solve. The answer is something called socio-technical lock-in, and it shapes every aspect of how we live our lives. Socio-technical lock-in is what happens when everything around a technology reinforces its use. Infrastructure, habits, institutions, economics, all pushing in the same direction, which makes switching to something better surprisingly difficult. Here's some common examples you might be familiar with. The classic typewriter worked by throwing levers stamped with letters against the paper, but there was a problem. If the levers were too close together, the keys got stuck. So the keyboard was laid out in such a way to keep common letter combinations far apart on the keyboard. The net result is that the QWERTY keyboard is inherently designed to be slow to type on. When we transitioned to computers, the layout stuck. We could have designed a faster layout of keys, but this never took off. Why? Because people's habits locked us into the existing technology. In order to break this, you'd have to teach everyone in the world how to type again.
If you've ever used a British sync, you'll know the problem. One tap freezes your hand, the other scalds them. Originally done for good health reasons, it's no longer necessary in a modern home. The mixer tap is quite simply a better piece of technology, but it's been very slow to get adopted in the UK. Why? Well, first, British people are culturally used to having two separate taps. But then, if you buy a new sink and you don't specify you want a mixer tap, you'll get the classic version anyway. But it runs even deeper than that. The plumber may prefer installing the old sinks that he's used to installing. So retailers still sell them, manufacturers still make them, and advertisers still promote them. You can see how easily we end up stuck using this old inferior technology because of a series of ingrained behaviours all the way through the supply chain.
Microsoft Word is generally reckoned not to be a great piece of word processing software, and better alternatives do exist. Even if you do switch platforms, you still need Microsoft Word, because everyone else is using it. This is the classic everyone needs to change at once problem. It just won't happen, so no one switches. So what's going on here? Well, all of these examples have some features in common. It's partially technical lock-in, where earlier technology choices restrict future options. And it's partially social lock-in, where user habits, institutions and culture amplify those choices. Put the two together and you get a self-reinforcing cycle. If a technology gains traction, it creates dependencies. Companies build products around it, schools teach it, workers get trained in it, and soon an entire ecosystem forms, making it expensive to disrupt or change. The best technology doesn't win. The technology that builds ecosystems, habits, standards and institutions around it wins. This means that switching to anything else, even if better, is incredibly difficult. You can't just swap one technology for another, because everything around it, including people, also needs to change. Now this is interesting in everyday life, but in energy systems it becomes a serious constraint, because it slows the transition away from fossil fuels. Even though cleaner and more efficient technologies already exist, lock-in to older options slows adoption. Let's take a look at three classic examples. Since the invention of the motor vehicle in the 1880s, an entire car-centric culture has followed worldwide. It's not just that we chose the car over the horse, it's that we built roads everywhere. We have zoning laws that separate homes and work, forcing commuting, suburbs that require car ownership, and a cultural identity around car ownership. We didn't just adopt cars, We built entire cities and cultures that depend on them. These decisions matter. In a European city like Copenhagen, emissions are around 4.7 tonnes per person. In an American city like Houston, it's over 14, roughly 3 times higher, and largely because of how the city has been built around the car. The people living there have little power to change this, so they're locked in to a certain pattern of living. Here's another example. Our electricity grids were built for a world of a few big power stations. Now we're trying to run them with millions of smaller generators. The physical infrastructure we have wasn't designed to support this, despite it being a sensible approach when it was originally built. But it's not just wires and pipes. The rules, pricing structures and engineering standards assume a 20th century topology. So instead of designing the grid around renewables, we're forcing renewables to adapt to fossil-era logic. That's structural lock-in baked into regulation and market design. Gas boilers are another classic infrastructure lock-in. Once a gas grid is laid, millions of homes install gas boilers. Builders then design homes around them. Gas utilities need continued throughput. Regulation supports cost recovery over decades. Skilled labour specialises in gas, and consumers get used to instant gas heat. Then heat pumps come along. They use 3 to 4 times less energy than a gas boiler, and it's vital to eliminate gas to get to net zero. But homes need retrofits, electric grids need upgrading, installers need retraining, gas companies resist asset stranding, and politicians fear backlash over household disruption. So when you bury steel pipes under every street, you don't just distribute gas, you create societal inertia. So how do you actually break this? The first step is to acknowledge that you can't solve socio-technical lock-in with better technology alone. You have to unwind an entire system. Here's 3 approaches. First, build the alternative system. Lock-in persists because alternatives are incomplete. An electric car is only better if there's somewhere to charge it. Heat pumps are only better if people know how to install them. And more efficient appliances are only better if they're available. New technologies don't win when they're better. They win when they're embedded in a complete system. Second, we have to actively destabilise the old system. This is the uncomfortable part. The old system doesn't quietly step aside, it has to be pushed. That can include removing fossil fuel subsidies, regulating phase-outs such as banning internal combustion engine vehicles, stricter efficiency standards, or planning reform. If we don't do this, the status quo wins, either by actively defending its position, or just because socio-technical systems inherently resist change. Third, we need to coordinate change across society. This is the hardest part of all. You need alignment between consumer behaviour, cultural expectation, government policy, and industry investment. Transitions fail when these are misaligned. Technology might exist, but no one adopts it. Policy might exist, but infrastructure lags. Consumers might want change, but can't afford it. So it all needs a guiding hand to ensure that everything is aligned. The reason the energy transition feels slow isn't because we lack solutions. It's because we're trying to change systems that were built to resist change. Energy systems last for decades. Cities last for centuries. And the decisions we've already made are still shaping what's possible today. The good news is that once systems start to shift, they can move fast, because the same forces that locked us into fossil fuels can lock us into something better. We didn't just build an energy system, we built a world that depends on it. And changing that world is the real challenge of climate change.